Hello, my name is Justin Chong, and today we're going to be talking about chain rule. So first off, let's just go over the basic rules of a derivative of a regular function. Let's see. Let's find the derivative of x squared plus 3x plus 4. So how we find a derivative of a variable, basically, you bring down the power to the side, multiply it by that, and then subtract the power on the top minus 1. So it'd be 2 minus 1, which would be 1, which would just be 2x. And then same thing for this one. The power right here is x to the 1. So 1 minus 1 is 0, and x to the 0 is always going to be 1. So it's 3 times 1, which is just 3. And then the derivative of a constant is always going to be 0. So it's just going to be 0. So the answer is going to be 2x plus 3. So let's move on to the actual chain rule. So we're using chain rule to find the derivative of a function inside a function. Basically, f of g of x would be an example of a function inside a function. So how will we find the derivative of this? Well, first you have to find the derivative of the outside, which is going to be f of x, and then keep the inside, because that's the derivative of the outside. And then you need to multiply it by the derivative inside, which would be g derivative like this. This would be the derivative of this function. So let's try out a practice problem. I will leave up the derivative right here of the chain rule. Okay, we'll use that as a guiding. So let's use one example. Okay, so let's do x plus 3 squared. Let's find the derivative of this. So let's pretend that the inside right here, this x plus 3, is going to be equal to x, a single variable. And then we'll find the outside, basically this whole thing. So instead of x plus 3 squared, let's think of it as x squared. So this is just like the previous problem we did. We would bring down the exponent down like this, 2x, and that would be the derivative of it. But instead, we had to plug in this derivative right here, this function, this x, because originally it's x plus 3. So it would be 2 times x plus 3. And we just simplify this out, which would be 2 plus 6, 2x plus 6. That would be our answer. So this is just like doing a derivative of a regular function, but instead we have another function inside a function. So let's try a different problem. Let's try a harder problem this time. So let's find the square root of x squared plus 3x plus 4. So as we know, square root is just going to be raising the whole expression to 1/2 power. So let's change this. It's going to be x squared plus 3x plus 4 to the 1/2 power. So we do the same thing as last time. We pretend like this x squared plus 3x plus 4 is equal to x. Pretend like this is a whole single function. We do the same thing. So it would be something like x to the 1/2 power. So we would bring down the 1/2 to the side, be 1/2 times x squared plus 3x plus 4 to the 1/2 minus 1, which would be negative 1/2. But we still have to find the inside. Remember that the derivative of the chain rule is the derivative of the outside times the derivative of the inside. So the derivative of the inside would be 2x plus 3. Now we have to simplify this. Remember, we cannot have this negative exponent right here because that's just not right. So to eliminate this negative exponent, we would bring down this exponent to the denominator like this. So the final answer would be 2x plus 3 all over 2 times the square root of x squared plus 3x plus 4. That'd be your final answer. So let's try an even harder problem. This time, let's do trigonometry. Let's use trigonometric functions. So let's say sine of cosine 2x. So we're just going to do the same thing right here. The f of x this time is going to be sine of cosine 2x. And then our inside is going to be, our g of x basically, is going to be cosine 2x. We're doing the same thing as we did last time. So we find the derivative outside, which is going to be the derivative of sine is going to be cosine. And we keep g of x inside the same. It's going to be cosine 2x. And then we define the derivative of the inside. So that's going to be, the derivative of cosine is going to be negative sine 2x. But we're not done yet because we still have to find the derivative of the inside right here as well, which is going to be 2. So this is the derivative of this, which is the derivative of this. This is basically chain rule in action. Now we just simplify this to finish this off. So we take negative 2 times cosine of cosine 2x times sine 2x. This is our final answer. Let's try an even harder problem this time. Why don't we include trigonometric functions and logarithmic functions as well? So, let's do tangent ln x squared. Okay, so we have to find the derivative of the outside. Again, the same thing. But first, we need to remember how to do the derivative of a logarithmic function again. So the derivative of ln is always going to be u prime over u. So that's what's going to be the derivative of that. But first, we're going to do the chain rule as well. So basically the derivative of tangent is going to be secant squared times g of x, which is just the inside. So we keep ln x the same, ln x squared. So now we have to find the derivative of the inside. The derivative of ln x squared, as I said, we would use this formula right here. The u would be x squared. So basically we have to find the derivative of x squared and divide it by u, which is going to be x squared. So the derivative of x squared would be 2x divided by x squared. Now we can simplify this one right here. Cancel out the x right here and then cancel out the square. It would be secant squared times ln x squared times 2 right here, all over x. This would be our final answer. Thank you for watching, and I hope this helped you learn how to use chain rule.